Hello, Indrajit, I am audible. Okay, okay, okay. Thank you. So let us wait 2 minutes more. Then after I'll start. Maybe another participants will join. Uh, okay, so let us start. So the first question is the stress tensor tau ij. The stress tensor tau ij is a tensor whether it is symmetric type, whether it is asymmetric type, isometric or non. So you have the four options for first question. So just try to think which option will be correct. The stress tensor tau ij. You can write in the chat box your answer, please. Hopefully, other participants will join today. Okay, so let me just explain you. So here tau ij is the stress tensor whether it is symmetric, asymmetric, isometric and non. So symmetric means what? If you are writing tau ij, whether it is equal to tau ji, if this is, then such type of tensor is known as symmetric tensor. So yes, definitely, this is the tau ij, that is shear stress term. You can write like that also. So tau ij is equal to tau ji. You can write very easily. Now I want to explain you a bit more. So as you know, your stress tensor, if you write 3 is to 3, so this is your sigma I tau ij tau ik. Similarly, tau ji tau, that is sigma again, j into j, and tau j into k, jk, not into. Now again your tau ki tau kj tau, or here sigma kk. So this is your, these three is your known as your principal stress and rest of your shear stress. So here you can see very clearly ij and ji. Here you have all total 9 terms, total 9, but out of 9 you have the 3 is similar, means tau ij is equal to tau ji. So this and this is similar. This is and this is your similar, and this one is similar. So here out of 9 term you need to calculate only 6 one. So these are the dependency. So that's why your tau ij is your symmetric. Means if you are able to write something, let us suppose x ij, sorry, x ij is equal to, if you are able to write something x y is equal to, or x is equal to ji, if these two things is similar, so we can say this is your symmetric one. But your, okay, but your sigma I and I, sigma j and j, these are not similar, these are the different. And what is ij? I is nothing but, it's you can say it is showing here the positions. If you are solving some domain of the fluid mechanics, if you have like that, so ij is nothing but, if you are writing this is I1, I2, I3, this is your J1, J2, J3, means row and column. So if this point is what? I1, J1. So that is the things here. Okay. So hope understand. Now let us move on the next question. Next question is very easy. Question number 2. Very easy question. So please just try to calculate. A fluid flow is given by V vector is equal to 8 x cube y minus 10 x square y j. So here you have cap. Find the shear strain rate. So here you need to calculate shear strain rate. Remember please. So just within 2 minutes please just try to calculate, and then after I'll just try to solve. Just try. If you not know, there is you can just try. You just think. You have 2 minutes. Within 2 minutes you think, then after I'll explain. No issue. Very easy question. Shear stress rate. Strain rate, not stress. Shear strain rate. Okay, you not know. Okay, let me just explain you. So here shear strain rate is nothing but, here you can see very clearly. So let me just show you the stress tensor. Similarly, you can write the strain tensor also. Strain tensor also you can write. Means here these three term, let us suppose x, and here your y, and here your z, and here is something different, here is something different. So these three are your principal strain rate. Now rest of your shear strain rate. So here you will write like the epsilon. So epsilon ij you can write ij, epsilon ik. Similarly here you can write epsilon ji, epsilon jk, epsilon ki, epsilon kj, and here you can write ii, epsilon ii, or you can use different symbol also, epsilon jj, epsilon kk. So here you need to calculate your shear strain rate. So shear strain rate formula is half. Here you have what? Here you have your V vector is what? V vector is nothing but U I cap plus V j cap plus W k cap. So here you have only U vector. Here you have only U 8x cube and V your minus 10x square y. These two things you have. So when you will write your equation, that is when you will solve this shear strain rate. So if you have these two, so you are only solve. You need to solve only epsilon xy. So what is the formula of this? Half del v by del x. So what will be the del v by del x? Once we will solve, it will del v by del x means del by del x minus 10 x square y. So you will get what? You will get 20 minus 20 xy. So here you need to write minus 20 xy plus del u by del y. So del u by del y is 0. Why? Because del u by del y is equal to del by del y 8x cube. So here it will be 0. There is no y term. So this will be the 0. So finally, 2, when you will divide this, you will get 10 xy. So this will be your final answer. So minus 10 xy will be your correct answer for question number 2. Hope you understand. Now let us move on the next one. Okay, remember please this what I have explained you. This is very important. These things, this equation. If you will remember these things, you are able to find out whether you have u value, whether you have y value, or whether you have the w value based on this k, j and I. This will help you. Let us, if the question was asking about the acceleration, so when you will solving the acceleration, you need to write only these u and v, no w. So just remember. Okay, so next question is which of these is a disadvantage of Navier-Stokes equation? Very famous equation, Navier-Stokes equation. We have discussed previously also about Navier-Stokes equation. So disadvantage here we need to talk. Option A, no independent equation for pressure. Disadvantage means why we are not able to solve Navier-Stokes equation for the complex problem. So this was in the sense of this, you need to select the option. No independent equation for pressure, no independent equation for temperature, no equation to find the density, no equation to find velocity. So here you have four options. Very important question. So please just try to write your answer in the chat box. Very easy. Just think on that. If you not know, you can just Google. This question you can Google. So you will remember for a long time. First you read the question, first understand, try to understand the option. If you are not able to understand and not able to recall your concepts, okay, you are telling no independent equation for pressure. Okay, so let me just go. Yes, option A is correct here. Remember, please. So, what is written actually in the detail? The Navier-Stokes equation do not have separate equation to find pressure values in different points. Pressure gradients are present in different moment equations, making it or dependent form. So what is actually talking? So you have Navier-Stokes equation in three dimensions: in x dimension, in y dimension, in a z dimension, and each your equation have minus delta p by delta x, minus delta p by delta y, minus delta p by delta z. So these three term in the three direction you have Navier-Stokes equation. So we have the question, what is how we will write the complete Navier-Stokes equation. So that in that question I discuss. So for that actually you not have independent equation for solve the pressure for pressure values. So this is the disadvantage. Now let us move on the next one. Okay, very easy question. So Newton's law of viscosity relates the pressure, velocity and temperature, shear stress and rate of strain rate. Option C, shear stress and velocity. Option D, rate of shear strain and temperature. So you have the four options. So please just try to write your answer in the chat box. Okay. So you are telling the option B, that is tau is proportional to du by dy, dynamic viscosity, and du by dy. Okay. So you are telling this one, right? Let me just write here. So you are telling tau is equal to dynamic viscosity del u by del y. Okay. So what is del u by del y? Let me just explain you. This is your u velocity and this is your depth. So for laminar flow, your velocity is like that. So your gradient is changing. If you will see your gradient changing from origin to when you are moving in the horizontal way, that is your on the horizontal axis it is your velocity and vertical axis your depth. So as you are moving horizontally or vertically, your gradient is changing. So this is your these things. Okay, this is your dynamic viscosity. So Newton's law of viscosity relates what? Pressure? No, there is no pressure term. Shear stress and rate of strain. You can say this one. Shear stress and velocity. No, rate of change of not velocity. It is relate the your strain rate and rate of shear strain and temperature. No, there is no temperature term. So your option here is B, shear stress and rate of shear strain. This is your shear stress and this is your rate of shear strain. Remember please. So this is your for option for question 4, your option B is correct. Now, the Newton's law of viscosity defines the relationship between the shear stress and shear rate of fluid subjected to mechanical stress. Okay. Next one. Next question is the vorticity in z direction is given by option A del u by del x plus del v by del y, option B del u by del x minus del v by del y, option C del u by del x plus del u by del y, option D del v by del x minus del u by del y. So you have four options please. And question is asking about vorticity in the z direction. You have, if this is the three dimension, if I draw here, this is your x direction, this is your lateral y direction, and this is your vertical z direction. So vorticity like that in the x direction, in the y direction like that, in the z direction is like that. So question is asking about this one, vorticity. So if I represent with omega, so omega in z direction you need to calculate. Or not calculate, just you need to write formula here. Or identify the formula and try to write your option in the chat box for question number 5. Okay. What you don't know. Okay, no issue. So let me just explain you. You will remember always. So for vorticity you always remember this we need to write in terms of curl. What is curl? So your this del operator into velocity vector. So what is del operator? Let me just explain you. So del operator is nothing but, sorry, del operator is, del operator is defined like that: del u by del x, del v by del y, not, this is not v, del by del x, del by del y j plus del by z k. So this is your del. And what is velocity vector? I have explained earlier also. Let me explain again right here. Ui plus vj plus wk. So when you will write cross product, so when you will try to calculate the cross product between these two, so you need to calculate like that. How? I, j, k, you will write this one del by del x, then del by del y, then del by del z. Then you will write velocity u, v, w. Just you take the here determinant. How I will write? So for your this one I, so this will be your w, del w by del y minus del v by del z minus again here your j, so del w by del x minus del v by del u by del z plus, if you are writing here k, then you need to multiply between these two. So del v by del u or del v by del x minus del u by del y. So this is your. Now you can represent with this omega vector, and omega vector is nothing but I wx plus wyj plus wzk. So question is asking about wz. So what is wz? You can write this one. So del v by del x minus del u by del y. So you can just find out del u by del x, no, del u by del x, del v by del x, yes, but here need to minus. So del u by del x, del v by del. So option D will be correct. So you need to remember how to calculate. Sometimes if you will forget, so you need to remember some slight mathematics behind it. So if you will remember, that will be very easy. So based on this, I think in the gate, many question you will find out in the gate examination. Also maybe NPTEL previous year also you will find out NPTEL your assignments. Okay, so now let us move on the question number 6. What is the magnitude of vorticity? What is the magnitude of vorticity? So twice of angular rotation, thrice of angular rotation, 2.5 times of angular rotation, same as angular rotation. So here you need to calculate the magnitude of vorticity. Question number 6. Very easy question. If you not know, you can Google, or if you know, just first you try to direct. I'll not recommend you direct. You need to Google it. Just read the question and read the option, then just think, just recall your concept. Then after you, if you not know, if you're not able to recall your concepts, then you can Google. That will be the best way and easy way. You will remember for a long time if you do in this way. Okay, you are telling the option A, that is twice of angular rotation. Yes, it is a twice of your angular rotation. Remember, sometimes vorticity is represented by this symbol, so 2 omega, or you can write direct vorticity also, no issue, that is 2 omega. Okay, so now I'll move on the next question, question number 7. Okay, so Navier-Stokes equation is derived from Euler equation, continuity equation, first law of thermodynamics, Newton's second law. Your Navier-Stokes equation is derived from Euler equation, continuity equation, first law of thermodynamics, Newton's second law. Question 5. Z also twice. Okay. What is Z here? Z I am not able to understand. Z direction. Yes, yes. For all, actually, this will be applicable for all. X direction, Y direction, Z direction, every. Now please just try to think about question number 7. Very fundamental question. Okay, you are telling for question number 7, option D, that is Newton's second law. Yes, your for Navier-Stokes equation, you need to solve, or you need to just try to write your equation based on Newton's second law. Means your force is equal to mass into acceleration, or your mass del rate of change of velocity, or m dot rate of change of mass into your change in velocity. So you need to write in this form. Actually, in the fluid mechanics we follow this one. So in fluid mechanics, any momentum equation, you need to solve your this very fundamental Newton's second law. So always remember this. So option D is correct here, definitely. So what is your Navier-Stokes equation? Here you can see the Navier-Stokes equation. That is your force. This is your force. Force, this combined, is equal to your rate of change of mass into your velocity. So here you can see your for the mass it is written your density and del v by or dv by dt. So you are able to understand. Hope you are able to correlate the things what I am talking. Mass is nothing but what is mass? Your density is equal to mass by volume. So your mass is density into volume. So for unit volume you can write this. Or once you will solve, then you will able to understand what is your dv by dt. Generally for dv by dt we know the material derivative. Little bit advanced. Material derivative. Okay, so I'll not go in much because at your undergraduate level, so that is enough for you. Okay, so now I will move on the next one. According to Stokes hypothesis, the coefficient of bulk viscosity is equal to, okay. According to Stokes hypothesis, the coefficient of bulk viscosity, your lambda, is equal to whether it is minus mu by 3, mu by your 3, or here answer is visible, no issue, and 2 mu by 3 and minus 2 mu by, yes, definitely your option D will be correct here, minus 2 mu by 3. So as per the Stokes hypothesis, your lambda is equal to, lambda here is your bulk viscosity. Coefficient of bulk viscosity is nothing but minus 2 by 3 mu. So I'll recommend you please go in detail what was the Stokes hypothesis and why your coefficient of bulk viscosity is equal to this. So I'll recommend after this class you can Google and try to find out this, the answer of this question make you very different, or make you different than the other student. So these are the some suggestions from my side. So please, if you are take interest in this subject. So if you know these things, why lambda is equal to minus 2 by 3 and what was the Stokes hypothesis, that will be make uh, you will stand out at different place than your other students. Okay, so now let us move on the next question, question number 9. The fluid flow out of a nozzle where the viscosity where the velocity field of the fluid is a function of position and time. This description represent, so here what question, let me just read again. The fluid flow out of a nozzle where the velocity field of fluid is a function of position and time. This description represent Lagrangian description, Eulerian description, both A and B not. So here you need to very, if you know very fundamental of fluid mechanics, then you are able to very easily, if you can give this answer. Otherwise, you will be difficult. Okay. Yes, definitely for the previous question, F was equal to ma. In fluid mechanics, you need to write the body force as well as the surface force, not like the rigid body equations. So fluid mechanics bit difficult than your rigid body motion, because here nothing like rigid. So always we talk about, always we write the equation in terms of the rate, because fluid always flow deform, so that's why. Okay, so you just please think about question number 9. Just try to draw the figure what the question is telling. The fluid flow out of nozzle where the velocity field, or at the place of velocity field you can think a particular particle, or particular the fluid parcel of the fluid, a fluid parcel of your the liquid or the considered fluid is a function of position and time. Then you are able to very easily you can understand the things, whether it will be the Lagrangian description, Eulerian description, or you can say the both. And what are the Lagrangian, what is the Eulerian, I'll explain. But just you please try to think. I'll explain very in the very easy way with some practical example. So before that, you need to think and try to write your answer in the chat box. And just try to recall your concept, please. So please just try to think, or you can just Google what is Lagrangian, what is Eulerian description. So based on this definition, you just try to understand the question number 9. Then you are able to give the answer also. So if you not know, please just Google it. The first, what is Lagrangian description, what is Eulerian description. Based on this, Whether your question 9 you can keep in Lagrangian description, in Eulerian, or both you can say. So this is another way how we will solve or how we will think. If you not know, if you know, just recall your concept. Very actually the very fundamental question. Before in the first class, actually the teachers or faculty talk about it. Okay, maybe I think the student have some network issue, so I'll wait 1 minute, then I'll explain. So if you not join within 1 minute, then I'll try to explain the things. What is your Lagrangian, what is Eulerian, and how we will think such type of question, whether it is Eulerian, your question will follow the Eulerian or the Lagrangian description. Okay, so let me explain. I think he has some network issue. So what is Lagrangian approach? Lagrangian approach, or you can say the description also. Your Lagrangian approach is nothing but, let us assume you have a river system like that and water is flowing. This is your inlet and this is your outlet. So I think he has joined. Okay. So I am audible, please. Just confirm whether I'm audible or not. You can write in the chat box also. Okay, no issue. So let me just explain my work. Okay, so here is you have the inlet and here you have the outlet. Okay, so now if you want to measure a velocity here, if you want to measure the velocity, let us suppose for the flow, whatever the water is flowing within this your channel, so how you will measure the, if you want to measure the velocity, you have the two way. One, you have to fix at this location your instrument. Your fixed instrument. Another, you have instrument like floating type instrument, means you will put your instrument here like that. This is your instrument and your instrument is floating with water, so it is giving at particular time here, at after 1 second it is here, after another second it is here, so it is moving with water. Means your instrument the capture particular fluid parcel, and your instrument tracking, that is as your fluid parcel is moving from one place to another place, your what is happening here, your instrument also moving with that fluid parcel only, means as you are changing the fluid parcel changing I and j direction, means the coordinate changing xyz direction, your instrument also changing with that, means your the particular fluid the particular fluid parcel, the instrument is measuring the velocity of particular fluid parcel. But once we will fix the instrument, what will happen, whatever the fluid is moving from here, whether this fluid or this fluid, there is no meaning, for each fluid passing at this location, that will measure your velocity. So there you have, here you have the two way. So first way, that is when you will fix the instrument, that is your Eulerian description. And when you will keep your instrument the floating type, the floating with a particular fluid parcel, so that is your Lagrangian description, means your fluid particle changing location, instrument also changing location. So what is, so in the Eulerian description generally we talk about control volume, means you will make a control volume like that, and within control volume you will try to analyze, you will try to write the equation. So generally your Navier-Stokes equation and all, Euler or the Bernoulli equation, we try to we calculate using your control volume approach. That is your fixed type of volume. We have fixed a section, we have fixed a section, and within section we are trying to analyze the things. So hope you understand. Now the question is talking about, so a fluid flow out of a nozzle, means you have a nozzle like that, you have nozzle like that, and the water is flowing from this nozzle like that. Okay, now the question is where the velocity field of fluid is a function of position and time. Your velocity is a your velocity is a function of position, that is x, and time, means your velocity is a function, means as your fluid particle moving from one location to another location, your velocity is following that things, means the position and time. So here position and time was for the fixed instrument is not following, not you're changing the position and time, but the instrument or the fluid parcel is changing the time and the position. So this question is falling in your Lagrangian description. So hope you understand the things. Question number 9. This was the very technical question, very easy question. So let me just read what here it is written. That is also very important. So detailed solution. The Lagrangian specification of the flow field is a way of looking at fluid motion where the observer, that is your instrument, follows an individual fluid parcel as it moves through space and time. Plotting the position of the individual parcel through time gives the path line of the parcel. And this can be visualized as sitting in a boat and drift down a river. That is the way. Okay, next, the Eulerian specification of the fluid field is a way of looking at fluid motion that focus on specific location in the space through which the fluid flow as time passes. This can be visualized by sitting on the bank of river and watching the water pass the fixed location, what I was discussing, the fixed and the moving. So here the question of the example was given, boat is moving in your what river. So that is next one. The Lagrangian and Eulerian specification of flow field are sometimes loosely denoted as the Lagrangian and Eulerian frame of reference. So we can say also these things. However, in general, both the Lagrangian and Eulerian specification of the flow field can be applied in any observed frame of reference and in any coordinate system used within the chosen frame of reference. So remember please, these are the some very technical things, very basic and technical also you can say. Now we'll move on the next question, question number 10. Very easy. Okay, so any other student join or not? Okay, one. So let me just explain you the question, read very carefully. Okay, so question 10 is the volume rate of flow Q between two streamline, that is your sigma 1 and sigma 2, is equal to 0 sigma 1 cross sigma 2, sigma 2 minus sigma 1, option D sigma 2 plus sigma 1. So here you have the volume flow of the volume rate of flow Q, that is del V volume by del T, volume flow rate Q small q between two streamlines. You have a streamline like that, your potential line like that. Hope you remember such type of net. So this is your phi, this is your psi, psi 1. Why this is happening? Psi 1, psi 2, psi 3, psi 4, phi 1, phi 2, phi 3, phi 4, phi 5, like that. So now, so between these two, the your volume flow rate, which is denoted by Q, is equal to your, here remember always please, that is psi 2 minus psi 1. This will be your volume flow rate, or in the question is given Q. So this will be your formula. How we will write? Integration psi 1 psi 2 del psi. This will be your formula. Integration, and when you will integrate you will get psi 2 minus psi 1. Q is equal to. So remember please. So this is the concept behind your, that is the volume flow rate between two streamline. Now we'll go on the, I have the lot of questions. This was your 2025, the same your hydraulic engineering 2025 previous year assignment. Now we'll solve the your 2024 also assignment 2024, 2024, same hydraulic engineering. Remember please. Okay, so maybe a student will join, so I'll stay in the call. So okay, so I'll take here the 5-minute break, then after I'll continue. So now let us move again. Your question number 2024, your assignment 2024. Uh, Let me just go on the PPT. Yes. So here you have we have 12 question. Previously we have solved the 10 question 2025 assignment, the hydraulic engineering. Now we are solving the your question number, assignment number, assignment year 2024. The question is, a highly viscous fluid flow at a low velocity is called steady flow, uniform flow, turbulent flow, laminar flow. Highly viscous fluid. Okay, highly viscous fluid having a the flowing at a low velocity is called. So let me just little bit explain you what question is, where question is your actually try to means where question is like the question itself, the telling what you need to think. So what question is telling, you have one flow have the highly viscous means question is indicating you need to think about Reynolds number. Why? Your Reynolds number is nothing but this is your, what is Reynolds number? Inertia force divided by viscous force. Inertia force divided by viscous force. Your Reynolds number. So here, if your viscous is more, that is your dynamic viscosity is more and more for particular water, particular flow, and velocity is low, then what will happen? Your flow will be very streamlined. Visually, I just try to explain you. And if the viscous force is the viscous force and your inertia force, if the viscous force is very high, your Reynolds number is also less. But how much less, how much high, this is some qualitative because your quantitative things is not there. So definitely this flow is indicating towards the laminar. Let me just check. Yes, it is laminar flow. So you have to think like that, then you are able to understand. So what is in detail solution? For viscous flow at low velocity, the fluid move in well-defined layer exhibit laminar flow. So visually you can say like that, and mathematically also you can think like that. Okay. So the next question is question number 2. The vorticity is, so this question we have already solved. Vorticity is nothing but that is 2 times of your rotation. 2 times of rotation. And what was the rotation? Rotation is nothing but your curl. I'll not explain more here. So already I have discussed in 2025 previous year question. So what was this? Your I, J and K. So this was your del by del X, del by del Y and del by del Z. And this was your U, V and W. And you need to write this, your I is equal to del W by del V minus del V by del Z minus J del W by del X minus del U by del Z plus K is equal to del v by del x minus del u by del y. So this is your this is your rotation. So rotation is your wxi plus wyj plus wk wzk. So this is your rotation in three direction. So when you will write this your verticity, this is just two times of your rotation. So remember please. So twice of the rotation. So this is your question number 2. Now we'll move on the next question, question number 3. So here in the detailed solution it is written the vorticity field is the curl of velocity field and is twice the rotation rate of fluid particles. Just definition is written. Okay. So now the question next, when the stream function exists, when a stream function exists, it means what the existence so in the fluid. So whether it is flow is steady and incompressible, the flow is uniform, the flow is turbulent. Option D, the function represent a possible flow field. So you have four options. Please just try to. Okay, so I think we have some network issue. Okay, what is happening? Network is okay. So no, we are not offline. Okay, something. So what is happening? It is working well. The internet is connected. So something problem. Okay, no issue. Anyway, I am recording the things, but the maybe if anyone joined that not able to see, so let me just correct my connection. Okay, I think now we have. Okay, now we have the internet. Sometimes may the problem, such type of problems happen, but we have to have some patience with the internet. Okay. Okay. So now it is visible in result. So in between actually for 1 or 2 minutes I was lost the internet, or maybe 2 3 minutes. So we are solving, maybe your internet was not, you are not able to connect, so your internet was not working, so no issue. So now I have already finished the previous one, 2025. Now I am solving the 2024 hydraulic engineering, the question number 3. And the question number 3 is, when a stream function exists, it means what? Your flow is steady and incompressible, your flow is uniform, the flow is turbulent, and the function represents a possible flow field. So this is the question. Now you can write your answer in the chat box based on your understanding. Just please think on that. So anyway, I have recorded all the things. So you will, once I'll upload the video, you will understand. You can see all the questions whatever I was solving when you are not present. Now please, you just think question number 3. If you know, you just write in the chat box. Otherwise, after 1 minute, I'll just solve. The stream function. When the stream function exists, it means what? It means function represent a possible flow field. Represent possible flow field. Remember please. If a stream function is exists in any fluid flow, so it means the function represent a possible flow field. Always remember. Now let us move on the next. What is the detailed solution? In a stream function, if stream function exists, the flow may be rotational or irrotational, a possible flow field. If it satisfies Laplace equation, then it is a case of irrotational flow. So this is the meaning. Now question number 4. If a stream function exists for a flow and satisfy Laplace equation, then the flow is rotational and satisfy the continuity equation, irrotational and satisfy the continuity equation. Option C, irrotational and does not satisfy the continuity equation. None of the above. If a stream function exists for a flow and satisfy the Laplace equation, then what is meaning? Just please try to read the question very carefully and try to write your answer in the chat box. I am waiting. Please just try to write your answer. I'll wait 1 minute more, then I'll explain you. Then I'll show you the answer. 1 minute more I'll wait. Okay, so let me just explain you. So a stream function if exists, what previously we have seen. So here you can see in the detailed solution also it is written very clearly. If a stream function exists, the flow may be rotational or irrotational. If a stream function exists, if your phi exists, what it indicate? The possible flow. The possible flow. And this flow may be your rotational or irrotational. The two things happen. Now, if you want to find out particularly where the flow is rotational or irrotational, you have to check one thing also. What? Whether your function satisfy the Laplace or not. If it is satisfy the Laplace, then it is your irrotational. Means your psi represent what? Possible flow, and the possible flow may be your irrotational, maybe rotational or maybe irrotational, and this will be checked with your, if Laplace satisfied then it is rotational, if Laplace not satisfied then it is your that is rotational, if it is satisfied then irrotational. Remember this. So the question was, if a stream function exists for a flow and satisfy the Laplace, means a stream function exists means your flow is possible. If Laplace equation satisfied, your flow is irrotational. Means possible irrotational flow, right? So here what is the option? Rotational? No. Irrotational and satisfy the continuity equation. Irrotational does not satisfy the continuity. No, it will be satisfy the continuity equation. That's why when your continuity equation satisfy means the possible flow. Remember. So option B will be correct here for question number 4. Now we'll move on the next one. The detailed solution. In a stream function exists, if a stream function exists, it is a possible case of fluid flow satisfied continuity equation, and which may be rotational or irrotational. If the stream function satisfy the Laplace equation, it is a case of rotational flow, irrotational flow. Remember. So for checking irrotational, you have criteria for Laplace. Now, next one. When velocity potential exists in a fluid flow, it means previously we were talking about psi, that is a stream function. Now we are talking about phi, that is velocity potential exists. Velocity potential function. When the velocity potential exists in a flow, it means the flow satisfy the condition of rotational flow, the vorticity is non-zero, the flow satisfy the condition of irrotational flow, all of them. So you have the 4 option again, very conceptual question. So anyway, you just try to think and try to write your answer in the chat box. I'm waiting, please. Okay, I think again the student have lost the connection, internet connectivity, no issue. So I'll explain anyway. I'm recording the session. So let me just wait 1 minute so he will get benefited. Okay, I'll wait 1 minute. If he'll join, if he will not join, then I'll explain. Velocity potential function. Okay, I think he has some connectivity issue. So let me just explain. So yes, if your velocity potential function exists in a fluid flow, then the flow satisfy the condition of irrotational. Remember, if your phi is exists, means flow satisfy the condition of irrotational flow. Existence of velocity potential function guarantee the irrotational flow. So here I'll explain one thing. You have phi and you have psi and you have phi. That is, this is your stream function and this is your velocity potential function. So if a fluid flow, this is your fluid flow. If in a fluid flow your phi exists, means your flow have irrotational. If in a fluid flow the psi exists, it represent the possible flow. And if this possible flow, if this phi follow the, that is satisfy the Laplace, then it is irrotational. Means for calculating the whether your flow is irrotational or not, here you need to, you have the two steps. You have to check also the Laplace. But here if it is exists, then your flow is irrotational. If the flow is irrotational, then your phi will be exist. So remember. So next question is, so here option C is correct. The flow satisfy the condition of irrotation. Okay, the laptop is fully charged. Okay, the question 6. The deletion of viscous term from Navier-Stokes equation is leads to Bernoulli equation, Euler equation, Torsey equation, Darcy's equation. So deletion means if you will delete, if you will remove the viscous term from Navier-Stokes equation, then the equation will become what? Whether it is Bernoulli's, Euler, Torricelli, and Darcy's. So what was your Navier-Stokes? Del V by dou T plus your force, your surface force, and plus body force. So within this force, surface force, you have the your viscous also. Remember please, viscous force. Now if you will remove this viscous term, when you will write this force, you will get the viscous term also within this. So if you will remove this viscous term, your equation will become the Euler. Remember please, this equation will become Euler equation. So detailed solution, Navier-Stokes equation take viscosity into account, while Euler equation model only inviscid flow. Means your viscous, means if you have some, here is the Euler and here is the Navier-Stokes. Euler equation, Navier-Stokes equation. So your what is the bridge? What is the gap? The gap is viscosity. Viscosity consideration. So your Navier-Stokes equation fulfill the limit because your fluid have viscosity. If you are solving your without viscosity, so your equation have limitations. But once you will consider the viscosity, then you have completely defining the flow. That is Navier-Stokes equation defining. So your Navier-Stokes equation fill the limitations of Euler equation, or you can say this viscosity term, the viscous consideration, that is the fill working as a bridge between these two. So you can define in your own way also, no issue. So that was the main thing. The difference, what is the difference between your Euler and the Navier-Stokes? The only is viscous term consideration. Now the question number 7. In question number 7, in fluid mechanics, continuity equation is a mathematical statement embodied embodying the principle of conservation of momentum, conservation of mass, conservation of energy, none of the above. Whether I have lost the connection or student have lost the connection. Okay, I have the connection also. Here we have the connections. Okay, so maybe student have lost. Okay, okay. Let me just record the session. No issue. We have lot of. I have lot of questions, so I'll solve. So the question is, in fluid mechanics, the continuity equation is a mathematical statement embodying the principle of conservation of momentum, conservation of mass, conservation of energy, none of them. So it is your conservation of mass. Remember please, continuity equation. Conservation of mass. Now the next, the bodily movement of a fluid element from one position to another in such a way that its new axes are parallel to original axis is defined as. Here, a body movement of fluid element okay, let me just close the video. Maybe sometimes due to the video you may face the glitch. Okay, so in such a way that its new axes are parallel to the original axis is defined as, means something, the fluid, let us suppose this is fluid element, it's moved from here to here, but the axis, this axis is parallel to the original one, means what, whether it is linear deformation, whether it is angular, whether it is linear translation, whether it is none of the above. So body movement from one position to another. Deformation means what? Deformation means this is your body and this is deformed like that. This is deformed like that, not moving. But one position to another, this is one position and this is two position. So this is known as deformation. This is known as your translation. And if the axis change, like initially was this and the x is now like this, so your angular, that is angular movement, but here the only translation is happening, which is the parallel of your axis from position 1 to 2, so definitely it will be the linear translation, always remember. So detail, the linear translation is the bodily movement of a fluid element from one position to another in such a way that its new axes are parallel to original axis. So remember. Okay, stay in call. Maybe another, maybe participant will join. No issue. Okay. So question number 9. During whether linear, angular, linear translation, none of the above, there is no shrinkage, stretching, or rotation of fluid element. During the linear, definitely when you will deform, then definitely your particle may be shrink, stretch. When angular deformation may be rotation, only you have one option, that is linear translation. In the linear translation, uh, there is no shrink, stretch, and rotation of the fluid element. So remember, these are the some definition. So remember. So detailed solution, the particle neither rotate nor get deformed. That is no change in size, shape, and orientation of the element during the linear translation. Okay. So next question. So what are the independent variable in Navier-Stokes equation? What are the independent variable? So what is independent variable? Let me just explain you. So let us suppose I want to calculate something, y is equal to 4a plus 5b plus c, means, or here I'll write the something 2, let me just write, no issue, anything you can write. So now your y, your the magnitude of the y will depend on a, b and c, means at the place of abc we can put anything that is independent. ABC is independent, but based on the value of abc your y depend. So here your independent is, so very fundamentally I'm just explaining you, independent variable is a, b, c, and dependent variable is your y. Similarly, in the Navier-Stokes equation, so your independent variable is what? Means you are able to put the value, independent variable. So it is your x, y, z and t. This is your independent variable. Means if you want to calculate at this location, so your x, y, z and t is changed. If you want to calculate at this location, your x, y, z change. Based on this location, you will get the final answer of velocity and pressure, whatever, in the Navier-Stokes equation when you will solve. So this is the meaning. Now, so here option D is correct for question number 10. Next question is question number 11. So details, in the detailed solution, there are 4 independent variable in Navier-Stokes equations, 3 spatial variable x, y, z and 1 time variable. So you have the 4 variable. Now let us move question number 11. The Navier-Stokes equation are coupled, uncoupled, exponential or radical system of equation. So these are the some mathematical term. So whether it is coupled, uncoupled, exponential, radical. So what are these term? So let me just read the detailed solution. Navier-Stokes equation are called a coupled system of equation because all of the equations should be solved to get dependent variable. Equation cannot be solved separately to get the unknown. Means coupled means, you if you have the Navier-Stokes equation, you have in the 3 dimension, x dimension, y direction, the z direction, you have the 3 direction equation. When you will solve combinedly these 3 equations, then you will able to find out your the variable that is an unknown value. So the thing here, The such type of dependency known as your couple type of equation. So always remember. So here option A will be correct for question number 11. Very easy question. So now we'll move on the next question, question number 12. Okay. So the Navier-Stokes equation are all partial differential equation. Yes. What will be the best reason behind this? Okay. So these are the some mathematical uh, thinking. So okay. So no issue. So option A, ordinary differential are not present in Navier-Stokes equation. This is the reason for why your Navier-Stokes equation are partial differential equation. Option B, the dependent variable are function of all independent variables. Option C, the each dependent variable depend on only one of the independent variables. Option D, the partial differentials are only present in Navier-Stokes equation. So you have the four options. Now the dependent variable are the function of, or option B is correct here, but what is B? The dependent variable are function of all. Remember the dependent variable, what are the independent and dependent, you know already. Independent x, y, z and t. The dependent variable are function of all of the independent variables, remember please. So that is the reason behind the why your Navier-Stokes equation is partial differential equation. Means your dependent variable, the velocity, your pressure, these are all the function of x, y, z and t. Also your velocity also x, y, z and t. So these are the things here. That is velocity in x direction, y direction, z direction, pressure in x, y, z direction. So just think on that. Now we'll move on the next. Okay, so we have the 12th question. So now I'll jump for assignment 2023. So we have already solved assignment 2025 previous year hydraulic engineering assignment, and 2024 also. Now I'll jump on 2023. So let me just read the detailed one. So each dependent variable in Navier-Stokes equation depend on all of the independent variables. So partial differentials are used to indicate that the other independent variables should be kept fixed with differentiating. Fixed while differentiating. So this is the some how we will differentiate the partial differential equation. The things is written here. So this is not big thing. Okay, so now we'll move on the next one, the assignment 2023 your hydraulic engineering. So the question was, one is the laminar viscous flow is characterized by Reynolds number which is less than the critical value, equal to the critical value, more than the critical value. Option D, none of the above. So here just think on that. So laminar and viscous flow we have already discussed, I think in the 2025 one. So the critical value is nothing but, critical value is what, when your Reynolds number changing from your uh, means if you have laminar flow, when the from laminar to changing in the another, that is transition or the turbulent, so that is the critical. That is for pipe flow you have Reynolds number critical one in the some book written 2000, 21, 100, 2300. So these are the critical things for pipe flow. So beyond this your flow will change, flow characteristics will change. So the limiting value, or you can say the threshold value. So definitely for laminar and viscous flow is characterized by Reynolds number which is less than the critical value. Option A will be correct here. Option 2, the ratio of velocity to the ratio of maximum velocity to average velocity for viscous fluid flow between two parallel plates means, always remember please. So this is a parallel plate. So the maximum V max and V average, the relation. And here also I want to explain about the pipe flow also. So V max and V average relation. In pipe flow, the V max is equal to 2 times of the V average. Remember these things. In parallel plate, your V max is equal to 1.5 times of your V average. So here your option C will be correct. Why? Because question is asking about parallel plates. And how it is, you know already the formulas. Sir has explained very well in the class, so you know very well. So this 3 by 2 which is come at 1.5. Option C will be correct for question number 2. Now question number 3. The vorticity represent the fluid properties of kinematic properties, transport, thermodynamic, other miscellaneous. The vorticity represent the fluid properties of, definitely we are, vorticity is nothing but is a kinematic properties. So here something is written in the detail. So kinematic properties, linear velocity, angular velocity, vorticity, acceleration, strain rate, these are the kinematic properties. Transport properties, your viscosity, thermal conductivity, mass diffusivity. Your thermodynamic properties, pressure, density, temperature, entropy, enthalpy. These are the thermodynamic properties. Next one. Which of the factor primarily decide whether the flow in a circular pipe is laminar or turbulent? Which of the factor primarily decide whether the flow in a circular pipe is laminar or turbulent? Prandtl number, the pressure gradient along the length of the pipe, the dynamic viscosity coefficient, the Reynolds number, you know very well. This non-dimensional number, Reynolds number defined, these are the things. The detailed solution, high Reynolds number that is greater than 4000 in pipe flow. This value is given against the pipe flow or turbulent flow, whereas the low Reynolds number less than 2100 are laminar flow. The viscosity coefficient is a part of the Reynolds number but isn't the only criteria for decision. Okay, good. Next one. Question number 5. Navier-Stokes equation is derived from Euler equation, continuity equation, first law of thermodynamics, second Newton's second law. So this question we have already solved. So definitely it is your force is equal to mass into acceleration. That is Newton's second law means your surface force, your body force combinedly is equal to your mass flow rate acceleration, that is rho dv by dt. Rho is what? It is representing the mass. What is rho? Mass by volume. So you can write for unit volume mass is equal to rho, and your here this is your velocity. So what is A? dv by dt. So just for relating this I am just explaining here. So remember this. So Newton's second law. Any momentum equation in the fluid mechanics we follow the your Newton's second law. Okay. Now the next question. The stress tensor tau is a tensor. Actually, this was the first question of the today discussion. This was the first question, so I'll not wait here more. So this is the symmetric type. When you will see the video, you will able to understand things I have explained earlier very well. So once you will see the complete, well, in the initial that was the first question, so you are able to understand, no issue. Now the next question: which of the following flow have the highest critical Reynolds number? Flow in pipe, flow between parallel plate, flow in pipe, okay, flow between parallel plate, okay, the flow in open channel, okay, the flow around spherical body, the flow around a spherical body. So we have the four options: one, two, three, four. So which one have the highest critical Reynolds number? So definitely with the pipe. How? And what is the others? What about others? So here in the details already it is written: approximate the lower critical Reynolds number for flow in pipe, flow between parallel plate, flow in open channel, and flow around a spherical body are, means 2000 corresponding to your pipe, 1000 corresponding to parallel plate, and open channel corresponding 500, and corresponding to a spherical body it is 1 respectively. So definitely here your pipe flow have more, 2000. Now we'll move on the next one, question number 8. The flow through a circular pipe is laminar. Now the fluid through a pipe is replaced with a more viscous fluid and pass through a pipe again with the same velocity. What can we say about the nature of this fluid? Whether it will be option A, the flow will become turbulent, the flow will be transient flow, the flow will remain laminar. Option D, the Reynolds number of earlier flow is required to answer this question. So here the question is, you have a circular pipe, fundamental question. You have circular pipe and fluid is flowing through it. Okay, flowing through a pipe is replaced with the more viscous. More viscous means initially let us suppose viscosity was x. Now in the second case your velocity your viscosity is dynamic viscosity is x plus, means increasing with the same velocity, but velocity here is, if this velocity is y, here also velocity is y. What we can say, the flow nature means your viscosity is increasing, your viscosity of the fluid increasing, means your viscous force is increasing. Your Reynolds number is what? Inertia force by viscous force. So now your inertia force is depend on velocity, viscous force is depend on your dynamic viscosity. So definitely your y is constant, but your this is increasing, means Reynolds number getting decreased. If Reynolds number getting decreased, the flow will remain laminar, because in first case was laminar here. So definitely if you are getting reducing the Reynolds number, means definitely your flow will be remain laminar. So option C is correct. Now the explanation is given very well here. Okay. So now when a problem state the velocity of water in a pipe is 20 meter per second, which of the following velocity is talking about? Whether it is RMS value, RMS velocity, average velocity, absolute velocity, or relative velocity. So it is your average velocity. Remember please, average velocity. And the question it is written. Next question. Here we can read this. In a pipe flow, the velocity is always referred to average velocity. There may be case where the water particle move in the same direction with 20 meter per second, then the average velocity will equal to absolute velocity. But this is only a special case, hence average velocity will always be true. Okay, this is the explanation, you can read. Now the same question, the volume rate of flow q small q between two streamline psi 1 psi 2 is equal to, it is a difference between these two. I have earlier explained, you can see. Next question is question number 11. In a flow fully developed pipe flow, how does the pressure varies with the length of the pipe? So it is linearly vary. In a zero acceleration fully developed flow in a pipe, the pressure gradually decreases linearly along the length of the pipe. Hence, the pressure variation is said to be linear. Means, in a zero acceleration, fully developed flow in a pipe, the pressure gradually decreases. Means your high pressure to low pressure flow going. This concept you remember, please. You always flow from high pressure to low pressure. Now the question number 12. So this is the last question for today. The question 12 is the viscous force, the relative motion between the viscous force. Okay, I think some the viscous force, the relative motion between adjacent layer of the fluid in motion. Which one of the flowing fits best the sentence? Whether it is oppose, never affect, facilitate, may affect under certain conditions. So here oppose. The viscous force oppose the layer. That is the main thing. The viscous force oppose the layer. So option A is correct here. Now viscosity is an internal friction of fluid in motion, and it is the property by the virtue of which the relative motion between two adjacent fluid layers is opposed. So this was about the today's session. So my next session will schedule, I'll just show you here the, okay. Okay, so next Sunday actually, I today I'm taking on Monday because of the on Saturday I was busy with my work on Sunday actually. So that's why, but the next class is scheduled on Sunday, no issue. Okay, so I think so that's all from my side today. So once we will see this for the today lecture, you will definitely will get something different. So thank you all. Thank you again.